All right. So, hello, everyone. Welcome to the Microelectronics and Semiconductors Showcase. My name is Asher Dunsky. And as you can see, I took a picture this morning of some of the various microelectronics and semiconductors I could find on my desk for the background here. So, I don't have to give any credit to a photographer except for myself. So today we're going to have one session. That's incorrect. It's a one session pitch event. It's going to go for about an hour, so it should end hopefully if we run everything on time perfectly on the hour. If we do not, I request that everyone continues to stay on for the extra, hopefully not more than 5 minutes that we go over, but hopefully this is going to be about an hour. The full event will be an hour. What our goal is, just for the folks who are joining who have never seen this, is that we're trying to bring more deep tech to market by using the community that we have, and that's by reaching out. As some folks on the call have seen, we reach out to quite a few different people, but it's also to do these showcases and bring everyone together. So we have this ecosystem where it's startups that are dual use, and then we have tech scouts that are both government and corporate and investors. And so the showcase events are focused around different technologies. Today is microelectronics and semiconductors. Next month, we're having aerospace and defense, but I'm getting ahead of myself on the slides. And companies get to present in this event. I think it's 4 or 5 companies are presenting their technologies and to a panel, and the panelists are going to ask questions. If you want to be connected with the companies, feel free to ask me after the event or during the event. Even I don't mind making connections. And the goal is again to bring more deep tech to market. In addition to that, that leads us to the guided introductions. So basically, aside from the events, some folks have recently seen that there's a lot of we do a lot of matchmaking. We try to find the right people, to connect and hopefully make some good introductions where folks are able to actually take this tech and move it along forward. Our next 2 showcases are aerospace and defense and advanced materials / advanced manufacturing, which is a mouthful. This is the opening session and presentation, which is going to last about 10 minutes. What I am going to do is I'm going to have some of the folks on the call. As I said, it's a little more intimate, but I'm going to have some of the folks on the call introduce themselves and tell us who they are, so that the presenting companies can have a good idea of who they're presenting to. So, Nilesh, you want to go first? I, I don't think I can hear you. Is it just on my end? I don't think I can hear you, Nilesh. Okay, I'll come back to you. I'll come back to you. Sergey, you want to go next?
Sure. Hi, everyone. My name is Sergey. I'm with Tel Venture Capital. We are a venture fund for a large Japanese equipment manufacturer for semiconductor industry. Our focus areas are primarily around semiconductor manufacturing technologies. Our peers in the industry are Applied Materials, Lam Research, ASML. Some of these companies you probably have heard of or know better than us. Our name is a little less known, yet we're in every single foundry globally, wherever advanced semiconductors are manufactured. Happy to connect with startups and other investors to discuss potential opportunities to collaborate. Thank you.
Absolutely. It's a pleasure to have you. Zachary, you want to go next?
Sure thing. Hey everyone, I'm Zachary Chow. I'm with Lockheed Martin Ventures, with a strategic venture arm of Lockheed Martin. I saw you flashed up defense tech, that's very relevant to what we do here at Lockheed Martin. Also cover advanced manufacturing. I saw you throw that up as well. But of course, more importantly, we're involved with high performance electronics and semiconductors. We're a $1 billion fund. We do 15 to 20 investments a year, and looking to grow our presence across the VC ecosystem. So looking forward to connect with everyone. Excited to be here.
Absolutely. It's a pleasure to have you. Gerald, do you want to go next?
Yeah, hi everyone. I'm Gerald. So I'm from GC Ventures. So we are the corporate venture of Thailand-based petrochemical company called PTT Global Chemical. In short, it's GC. So venture team is GC Ventures. We look at sustainability and also advanced materials for the fast-moving, higher margin advanced sectors such as semiconductor, aerospace, and etc. So glad to be here and learning more from the startups.
Absolutely. It's a pleasure to have you. And Nilesh posted, I'm going to read it if that's okay with everyone. Um, Nilesh Trivedi, based in the Bay Area, he's managing $110 million across two funds, investing in semiconductors, defense, enterprise AI, and everything, mostly not consumer, seed to Series B. All right. Thank you, Nilesh, for the introduction. Lindsay, you want to go next?
Yeah, hi. Good afternoon, everyone. Lindsay Aspergren. I'm a special partner at NTT VC. We're a $500 million fund based in Menlo Park. We do early stage investing primarily. We're independent of kind of the corporate NTT structure and look for kind of best in class investments globally, focused on things in obviously infra, a data center, and beyond. Nice to see all of you.
Absolutely. It's a pleasure to have you. Next up, Jonathan, you want to go? Jonathan Wu?
Hi, John from ITIC. ITIC is the venture arm of E3, ITRI, one of the largest research organization here in Taiwan. And some notable spin-off you guys may know, including TSMC and UMC, AUO. So E3, besides semiconductor display, we also have research in bio life sciences and also mechanical engineering. So all kind of different deep tech in general. So we invest in Series C to Series B mostly. And thank you.
It's a pleasure to have you. And so I think with that, we're going to get started. We're 2 minutes early, which is the perfect amount of being early, in my opinion. We're going to start off with Inosys, and presenting, I believe, will be Steve, if I'm not mistaken. He can correct me if I'm wrong.
Yeah, that's correct, Asher.
Oh, great. Fantastic.
Awesome. If I can find my PowerPoint.
Worst comes to worst, we've done it in the past. Brian can also share if need be, hopefully.
Uh, okay, can you see my screen?
We can see it, but it's not on presenter mode yet.
Yeah?
Now it is.
Okay, wonderful. All right. Thanks again, and thanks everyone for being here. My name is Steve Cox. I'm not related to the governor of Utah, where one of the largest data centers is going up right now. But I did want to talk to you today about where is waste heat energy recovery to electricity? Our tagline is where it can be everywhere. Let me start with a little bit about Inosys, the company. We're not exactly a startup. We have been around since 2000. We're a women-owned small business. We were founded in the year 2000 by Dr. Jennifer Wu, who I believe is on the call. We have a very large manufacturing facility in Salt Lake City, Utah. We have more than 30 engineers on staff. We have more than 40 patents, with many still pending. And we do a lot of things here at Inosys. We do microelectronics fabrication, we do additive manufacturing, packaging and testing, and now we are recovering waste heat from facilities like data centers and converting it into usable electrical energy. So the problem is that every single time you run any machine, there is waste heat that is lost, whether it's an engine, a turbine. Essentially, any industrial process is going to create some level of heat that has to be disposed of. Uh, right now, companies generate that heat, they pay for it, and they essentially throw it away into the ambient environment. One of the biggest problems we see right now is most of this industrial heat waste is too cold, meaning it's not enough to generate actual electrical power. And furthermore, these systems that do exist, they really are trading a set of problems, generating this heat waste for other problems. They require a number of different moving parts. They require fluid to work that can cause gunking, and it requires a lot of expensive maintenance. So the solution where comes in is we are a novel device that takes this weight heat and converts it into usable electrical power for um, systems in defense, in commercial applications, and we really massively reduce that additive need for external cooling requirements. Those extra cooling requirements, they're expensive for systems like, off-world systems like landers, satellites, etc. Those alone require extremely complex cooling mechanisms that they themselves can break down. We're solid state, we don't require that. And we improve the thermal management. So, whereas what exists today requires much higher temperatures, we can operate at extremely lower temperatures, which improves the thermal management margin. The process, I mean, this is not, obviously doesn't go into the great details. I don't think anyone on the call would want to see, too much of the sciencey stuff, but essentially it's a very simple process. We input the heat waste. It's delivered via something called a heat pipe. We convert through our wear system it into usable electricity. So that waste heat goes just directly back into the facility, the system as usable electrical power. And this can be used in defense, space, industrial, and commercial applications. You'll hear me talk a lot about data centers today. We have the world's largest data center on the brink of going up just outside of where we live here in Salt Lake City, Utah. And one of the problems that this is facing, why it's getting some pushback from people in the state, is that it's projected to raise the ambient temperature in the evening. And this data center will be about 2.5 times the size of Manhattan. It will increase the ambient temperature in the evening by about 17 degrees, which means there will be no more dew point. Yes, so the kinds of problems that we'll have to the surrounding environment could be pretty significant. And that's because of the first law of thermodynamics. You cannot just get rid of heat once it's generated. You have to put it somewhere. Our system will take it, convert it into electricity, and put it just directly back into the system. And so the advantages here is it's extremely high efficiency, and it works under a number of different temperatures. So again, as I've said, traditional heat waste recovery only works really well with very high temperatures. We don't need high temperatures. And they also need those third-party moving parts, fluid, etc. that requires a ton of maintenance. So we're great for medium and low efficiency. And as I'm hearing myself, I apologize for my voice. I have bronchitis, but don't worry about that. Um, it's just a much broader application for a lot of different systems other than those that just generate really high temperatures. So to just go over those advantages, again, we can take waste heat recovery, use it both in space but also terrestrial systems, which again, given this current environment, is extremely timely and useful. We can use high temperature environment support. So again, it's going into electrical energy for electronic devices, and it reduces that concept of swap C, size, weight, and power plus cost. Cost is huge, again, because in situations where you're not able to provide maintenance for these systems, that system itself is another point of failure that can go down. And we are great for low-grade waste heat applications. So again, I know I keep saying this over and over, but it really is a hole in the market. Medium to low waste heat recovery is just not possible or practical right now. And then going back to the data centers, as I'm sure you all know, they are going up all over the country. Our partners who are on the call, we're on the phone with Utah state officials. We have, I believe, 34 data centers just in the state of Utah that are online right now or in the planning phase, including Kevin O'Leary's largest data center in the world that's being scoped out right now. So this market, this addressable market, is absolutely huge and is growing really, really quickly. I think everybody on the call knows that. The systems right now that are addressing trying to recapture this waste heat and these data centers generate an enormous amount of waste heat, and the current solutions, they're substandard. They require those moving parts. It's just one more thing you need personnel for. You have maintenance that can go down and cause downtime at the data centers. It's not an ideal solution. Other things like district heating, this is where, like places in Helsinki or Iceland, where they take facilities and if it's nearby a city or building structures, that waste heat can be used to heat buildings. That's just not the case with most data centers. And really, right now, there's not a solid state solution that exists. These solid state solutions just really don't require much maintenance whatsoever.
30 second
So,
warning.
how long?
30-second warning.
30 seconds. Oh, Asher, you're killing me. So we install in line with existing thermal management. And again, this electricity flows back into the facility directly. I will leave the TAM and the SAM to you guys. I'm sure you're probably already pretty familiar with it with data centers, and talk a little bit about our leadership. So Jennifer Wu founded the company. She's a PhD. She has served as CEO since the year 2000. She was a tenured professor at the University of Utah. She's got a lot of experience in extremely sciencey things. And I did want to point out, I think it was 2 weeks ago, she won the Utah Governor's Medal for Science and Technology. So we're incredibly proud about that. Larry Sadwick is also a co-founder and CTO. He is also a PhD from UCLA. He's a tenured professor at the University of Utah, has lots of commercial experience and a lot of experience in extremely hardcore electrical engineering subjects. And then I'm the CMO. I've got more than 25 years B2B experience with companies like Viasat, Hewlett Packard Enterprise, Cisco, etc. So you are in good hands there. And then really what we're looking for is not just investment, but really synergistic and strategic collaborations. If you guys do have inroads into especially data centers, that's where we're most interested right now. If you've got those relationships and some investment you'd like to add with us, we would really love to talk with you. So that is it. I probably just made it, Asher. Yeah, at 30 seconds. Did I nail it? If you have
Yeah,
questions, thanks, you guys. If you have questions, we'd love to hear them.
sure. And just in case anyone yeah, in case anyone wants to ask, or in the case that people do ask, right? Of course they should, right? Feel free to raise your hand or just blurt out because it's a good group. Yeah, it's under reactions on the Zoom bar. uh I can show you guys the raise hand. So that's my raised hand. So we open up the floor. Gerald, you go first.
Yeah, so thanks for the presentation, Steve. So yeah, I have several questions, but I don't want to take all the time. Maybe just should one or two. So about your heat source, are you going to capture the heat from gas or liquid or from solid? And what's the effective temperature that your system can capture the heat from?
Jennifer or Larry, would you like to address that or would you like me to?
I can talk about real quick. Sorry, I got feedback. Hang on a second. So basically we can use most types of media where most simplest one would just be basically, can you hear me okay?
Yep.
Yes, we can hear you.
Would just be basically contact, it would be a hot surface and contact. But we could use gas, we could use liquid. All those are possible. That's more of I think, an infrastructure that we attach to than our particular technology. And the temperature range can right now, it's still higher than probably some data centers. We're probably 500 degrees C and above, going toward 400 degrees C. Theoretically, I think we can get down to 200 degrees C as the ultimate goal. Right now, we're again looking at applications that are about 500 degrees C and above.
Okay. Yeah. Thanks so much.
Absolutely.
No one else has a question. Gerald, if you want to ask another
Oh,
one, if you
okay,
can.
okay.
Unless
Yeah.
someone wants to butt in. If anyone else wants to butt in, they can.
Okay,
But
so
Gerald, go
yeah, if
ahead.
I can fill into another question. So what was your conversion efficiency or yield, like percentage? And also we used to talk to another company called ATS Energy. So I think they're using thermoelectric materials. So what's your differentiation from them?
So that's probably a great question for you. And you're on mute.
All right.
Can you hear me now?
Uh,
So we're not thermoelectric. We're different. And we so the second part of your question was the temperature range or
Is the efficiency, or yield.
efficiency. Sorry, yeah,
Yeah.
efficiency.
Yeah.
Efficiency depends on temperature to some extent. It can be up to about 80%, which is much higher than thermoelectrics, which are a single digit.
Mhm.
So hopefully that answers that question.
Yeah, thanks. Thanks very much, Judith. Yeah, happy to follow up with you, and we can discuss in detail. Since we have some flue gas with high temperatures, so not data center application you prefer, but yeah, there's some real demand from our Thailand headquarters. Yeah, we'll follow up with you after the call.
Fantastic.
Excellent, Jared. Thank you so much.
Perfect. Awesome. Thank you, Gerald. Thank you, Steve. Thank you, Larry and Jen. I saw you on mute for a second there. That's the time we have. But yeah, feel free to share the information that's on the screen with the folks in the chat so that they can click on it more easily. Next up, we have Orbis Electric, and I believe Marcus will be presenting for us today. Whenever you guys are ready to go.
Thank you. Thank you, Asher. Thanks, everyone who is in attendance. Thanks for the opportunity. Let me pull my deck up and we'll get started. Let's see. Okay. Well, as I'm getting this to full scale, I'm Marcus Hayes. I am the CEO and founder of Orbis Electric. Orbis Electric is a deep tech company that's been in business for 11 years. Our background is developing proprietary permanent magnet motors and electronics, full stack drivetrain for automotive, undersea vehicles, refrigeration systems. And like everyone, when we saw the problems that data centers are incurring on many, many levels, it was kind of obvious to me and our team that see if I can get this thing to work. There we go. Yes. It was obvious to our team that we
We're
could
seeing
bring.
the wrong. We're not seeing your screen. We're seeing like the toolbar somehow. At
Really?
least, yeah.
Okay. There's some interference between uh, the Acrobat and
Zoom.
all right.
Perfect.
Working now? Yay.
Yep.
Thank you. But just to recap, so Orbis Electric, 11 years, deep tech, producing novel, proprietary, patented permanent magnet motor control architecture, started in EVs, Volkswagen Group, piloting customer, Wabash National, refrigeration systems capturing kinetic energy, L3 Harris, undersea unmanned vehicles. And so, in the observation that we had all made, as many of us have, about data centers and the coming slew of problems associated with them, we felt we could be a solution provider. So, we say we're positioned at the intersection of AI power and infrastructure. And we will now tell you how. I think we're all familiar with these numbers, worth addressing again. 30 to 40% of the energy or power into a facility goes towards cooling. Watts are worth a lot. And so the productivity of these systems, whether in the last presenter's case, we're talking about waste heat, there's extraordinary amount of energy or power being consumed unnecessarily with antiquated systems, holdovers from the HVAC era. In our case, what Orbis does, in essentially in the simplest possible context, is we replace legacy 483 phase induction motors, which have significant heat, significant power consumption for substantially less value than a permanent magnet motor would offer. If the value of the energy wasn't so precious in these systems, one could suggest that the expense of a permanent magnet motor by comparison to an old school induction would normally be a more difficult cost benefit equation, but it returns value almost instantaneously. The numbers are staggeringly large. And so what we have is a technology, as I mentioned, permanent magnet rooted called Halo Drive. It's been deployed in a multitude of different extreme environments, undersea, on trucks, in vehicles. And part of that stack is what we call the Silicon Utilization and Reliability Framework, which is essentially a fun trademark for describing how we control the permanent magnet motor relative to its environment. And so in permanent magnet motors, unlike induction motors, the responsiveness of a permanent magnet motor is as much as 100 times faster than induction. So where is the value of this technology? All the liquid cooling systems, for those of you who have been following the trends in data centers, all of the liquid cooling systems, whether it's direct immersion or direct to chip, obviously HVAC has been outclassed, traditional air liquid outclassed. In liquid, which is what Orbis Electric is supporting, liquid direct to chip or direct immersion. The incumbents are VFD-AC, essentially rooted. We are the first people into this market with a DC native 800 volt, but important to mention that not just DC native, but power agnostic. So whether the data center is a 43 phase or it eventually becomes an 800 volt DC native aligned with NVIDIA's institutional strategy, Orbis Halo Drive is both. It doesn't require the customer to wait for any change in the architecture of the data center. So we're brownfield, greenfield. The numbers are staggeringly high. We've got roughly 49 patents working. 16 of those are issued. We're talking to the hyperscalers. We've got our first customer on data center cooling side, Air2O, where we're doing piloting. This is also an infrastructure aligned play in that the Department of Energy has just released a program, a loan program that's modeled on the EV program of yore, where money from the Department of Energy, U.S. government's being loaned to companies potentially like ours that address infrastructure bottlenecks. And so the biggest gain ultimately for us, an enormous market, opportunities outside of direct cooling, whether it's rear door heat exchanger, chillers, even BESS, thermal, are all future market opportunities. But the upshot here, and the most important thing, is that the value of what we do can be measured by any licensed electrician. You do not have to be a PhD to understand what our value proposition is. It all starts in something called the minimum circuit ampacity. Now to our commercial model and scale path. As I mentioned, we have existing customers, all of whom are migrating from what have in some cases been long-term pilots into growth and scale, most notably Air2O, a data center infrastructure company based in Phoenix that will be our rollout partner. We're projecting roughly $4.5 million in revenue. We are looking to raise $3 million on a bridge this year to coincide with that $4.5 million in revenue, as that takes us to a Series A sometimes next year. Strong team. We've got somebody from Intel, Oracle, Microsoft, who has built billions of dollars of data centers during his tenures at those companies, supporting my co-founder, who is a strong business builder, has a deep background in building international manufacturing and distribution programs. Our CFO has built a fractional CFO company that they've done about 50 billion in transactions since they launched 20 years ago. And then my background is 25 years in EVs, going all the way back to the first EV, EV1, Paul McCready, AeroVironment, and others. So we like to say we free power for AI, and the upshot is this, that the minimum circuit ampacity of our technology versus the 483 phase motor reduces the upstream infrastructure by roughly 40%. That means all the bottlenecks that we're seeing in transformers, switchgear, et cetera, are what Orbis frees to then reallocate that power to the place where it really needs to be, which is on the IT side of the building. Thank you.
Cool. Thank you, Marcus. Opening up the floor for questions. I have one queued up on my own, but happy to give other people a chance.
Great.
All right, cool. I'll uh I'll go for it. In terms of can you talk a little bit about it in terms of like a lot of the data centers that we're seeing now, it's like new construction. So can you talk a little bit more about, how it impacts, the MCA, how it would impact, how Orbis would impact new construction on data centers?
Sure. Well, the MCA is the so-called nameplate stamp on all of the equipment that goes into any construction project. So it tells the builder, the contractors, the architects how much copper, what the circuitry, the breakers, transistors, on and on and on. So everything that goes into that construction process is rooted in a very simple starting point, the MCA. In the case of our motors with a 49 to 50% lower MCA, that means that all of that circuitry, all of those transformers that would normally be allocated to the cooling side of the building, which is very low productivity but very high cost, can be shifted to the IT. So there's ultimately a 30 to 40% reallocation of power from the cooling side of the building to the IT. And in a greenfield building construction, that's about 200 million in savings on a 100 megawatt build out. The numbers are staggeringly huge. And on an annualized basis, in terms of the power reallocation, it's 20 million a year, plus minus. So that means any liquid cooling system that has our motors inside, the data center operator is going to recover that cooling technology in about a month. So on a 100 megawatt facility, for example, the cooling technology would be 12 to 16 million dollars, and that investment is recovered inside of a month based on both the greenfield savings and also the energy savings.
Okay, that makes sense. All
Um,
right, go for it.
uh, can you tell us a little bit about the history of the company? It seems like you've been in business for a while, and what its financing presently is, like who the investors are, and
Yeah, we've raised 13 million in call it an extended seed with high net worth Bay Area
okay.
influencers, among others, and so in the deep tech space, as you know, there are these and have been protracted pilots, both on the defense side of our business, on the mobile refrigeration side, and also in EV. The exciting thing with the growth in data centers, though, is that all of that accumulated experience and all of the miles literally that have been put on our technology in these extreme environments makes our growth trajectory now something that we can finally accelerate into. So yeah, we're raising another 3 million bridge, and that will take us with 4.5 million in revenue this year into our AA.
Okay. Thank you.
Thank you.
Perfect. I think that's the time we have. Thank you so much for the presentation, Marcus, and feel free to leave your contact information in the chat.
Thank you.
Absolutely. Next up, we have Sumit. Sumit, feel free to go right ahead whenever you're
Thank
ready.
you. Thank you, Asher. Appreciate it. So, hello everyone. Really excited to be here. I've seen a lot of faces that I have been hoping to talk to. So, um, let me just give you a quick background here. I'm Sumit Gandhi, the CEO and founder of AGC Power. We are an early stage startup, pretty much in pre-seed stage. So we would be raising our first round here. We are really trying to bring a new change in the quantum computing world because we are going to be talking about room temperature, photonic quantum computing architecture, and quantum sensors. And I know you guys have probably heard about a lot about quantum, how it's going to change the world. We think that in the quantum world itself will probably bring a tectonic shift. So how is that? So to give you a little bit more perspective, quantum has been talked about this very hard to comprehend topic. It's been like big, massive refrigerations, which I'll show you the photos later on. But what we trying to do here is bring quantum computing chips and quantum sensors for both civilian and defense applications. And in civilian, it's hard to comprehend for a lot of people, but we believe that we can bring quantum computing chips in future for phones, laptops, data centers as well. And you won't probably hear about quantum and devices going the way we are talking. And when we talk about quantum computing chips, our current projections is that we can bring almost a million qubit per second on each of these devices with a single chip that is 1 centimeter square wide. So obviously we can increase the quantum computing capabilities by adding more chips. So what is it that is so different about us? Well, you guys have heard about probably a lot of different quantum computing technologies like superconducting, neutral atom trapped ions, silicon photonics, many out there. But then there's most of these, as you see, they are operating in a regime which are silicon based, or what I call them are low band gap semiconductors. There's a lot of funding going on silicon based quantum technologies. There are more complexities added because I know there's a lot of funding on heterogeneous based quantum technologies. That is the underlying technology behind that is still silicon, but silicon brings with it a lot of different issues. And so we decided to take a different look at it. It's not that one of the quantum computing technology is better than the other, but by looking at three nitride, which are ultra wide band gap semiconductors, what we realized is that we can bring new capabilities in the quantum world that does not exist today. And by that, what I mean is that we can target in what is called as deep UV to visible range capabilities. So where does these deep UV to visible range capabilities add real value? Well, defense is obviously the number one place because defense operates in radiation hardened zone. They need SWaP-C2 capabilities. They're operating in space and they want SWaP-C. So really for what we call warfighter capabilities, deep UV to visible range is really important. But that also means that we can use it in other places. Now, so what values are we creating here? So as I mentioned, silicon is a narrow bandgap semiconductor. On the left side, you've probably seen, many have seen quantum refrigeration and cryogenic systems out there. They require heavy infrastructure and they are more prone to error. Now, instead of doing that complex, cost prohibitive, what many people call as utility scale, we want our quantum chip to look more like what you see in Raspberry Pi or even in your phones and laptops. So we want our quantum computing chip to look like this rather than all the heavy infrastructure around it. And when you have a chip like this small, you can literally use it in any electronic device the way you want it. And as I mentioned, the biggest advantage is the SWaP-C2 capabilities. It is a very simple architecture. very stable state because of ultra wide bandgap semiconductors. And also because it is ultra wide bandgap semiconductors, the errors are less, mainly because what we call two photon absorption. There are many issues with quantum world, and I can talk to you about it separately. But we have modeled and these error states and come out with our assessment of what we can achieve. And in quantum state, even with a ultra wide band gap material, we can achieve what we call 99.999% efficiency. So this, even at room temperature, would be as effective as a cryogenic quantum computing chip. So our underlying technology is based on blue LED light. Why blue LED light? I don't know if many of you remember, but the blue LED light innovator, Dr. Shuji Nakamura, who's from UCSB, he actually got a Nobel Prize for inventing blue LED light. We don't think about it as much today because we use blue LED lights everywhere. But we came out with the conclusion that if I can build a blue LED light in a foundry, I can add 5 to 6 more layers on top of that, and that becomes my quantum computing chip. And so when I am able to use the blue LED light to make a quantum computing chip, my quantum computing chip cost goes down drastically, almost to the cost of an LED light. Isn't that amazing? Because we talk about billions of dollars being spent on quantum computing. And here we are coming and saying, I can make a quantum computing chip and quantum sensor out of a blue LED light. So, with that said, our final architecture would look somewhat like a Raspberry Pi. And this chip, which would go in your phones, laptops, data centers, or civilian device or defense application, would still be 50,000 times faster than the best supercomputer that exists out there. Isn't that amazing? That we are so close to achieving something like that.
1 minute
So,
warning.
okay, almost done. So again, what we plan to bring is very specifically warfighter benefits, like hypersonic missile, plume detection, and exhaust discrimination. And our first target is obviously to focus on quantum sensors. So I know that there are people here from defense industry, there are people here from foundries. We are really looking to partner with you guys to build our sensors very quickly. And because our chip is really simple, our time horizons are much shorter to go to market. And so I would love to talk to you guys more about this, quantum sensors and quantum computing. With that said, I think financial projections are based on early quantum sensing and then on quantum computing markets. TAM SAM is much broader because of the wide application of the quantum computing chips. And lastly, I think we have a commitment from one of the investors for roughly 3.5 million. What we are really looking to do is, if you are a foundry or a defense company, understand your needs, what your capabilities are, and see how we can partner with you and go to the market as soon as possible. And the last part, we'll work on IP licensing, hardware, and different partnership with different folks. So let's discuss if you are interested. Regarding our team, this is the last slide, Asher. So as I mentioned, Dr. Shuji Nakamura, who is a Nobel Prize winner, he's also a collaborator with us. Dr. Stephen Denbas at UCSB is a collaborator. So we have a great team. We are based in Connecticut, and I know the state of Connecticut is also going to bring another $120 million in the space of quantum. So we are talking with UConn. I think we have a very exciting future in the quantum space, and hopefully you'll hear a lot more from us in the near future. I think with that, I'll open to questions out here. Thank you, guys.
Absolutely. Thank you. Nate. All right. Feel free to jump in and ask questions. Zach, go right ahead.
Yeah, thanks. So was curious, like how many qubits are you currently integrating, and what's your path to get to the 1 million?
So we are looking to build our first POC, I think, right now. And that for the POC is where we are looking to raise the pre-seed capital. And so we already have the guys available. We have some investment ready for it. I think our objective is to get it around 16 to 18 months, demonstrate not just the million qubits, but the architecture viability at room temperature to show that for especially somebody like Lockheed Martin, if you guys need SWAP C2 capabilities for your warfighters, I think that is our first demonstration step.
Thanks.
Sure.
Cool.
Can
Anyone
I
else
ask a
want to ask?
question?
Yeah, go for it.
Yeah, sorry, I don't have a way to raise my hand on the mobile. Thank you for your presentation. I just wanted to check if this process is compatible with existing foundry processes or if there's any changes required for the manufacturing side.
So depends whether you are on the silicon side or are you on LED manufacturing side. If you're on the LED side, this is an add-on process for you. It can take your existing LED process and we can other capabilities, other additions to it are much simpler. So if you are, I don't know which side of the foundry you are working on, but if you're on ultra wide band gap semiconductor, I think this is a really interesting space for you guys.
Yeah, we're typically on the silicon side on the equipment, but I would love to explore opportunities to collaborate after the call. Thank you.
Sure. Thank you.
Nice.
I had a quick question. I may have missed it, but how does your qubit work? What makes up your qubit?
It's a photonic qubit. So basically, we take the source of light coming from the blue LED. Blue LED light goes in and it goes into two separate signal and idler through what we call SPDC. So instead of using what typical quantum architectures use four-wave mixing, we don't. We use what is called a spontaneous parametric down conversion, SPDC. So the single source of photon breaks into signal and idler.
Okay. And
Yeah.
I see. All right. I still have to come to grips with that, but
Yes.
that's for later.
Yeah, no, I can sit down separately, go over it and talk about it, but it's a very different architecture. And because if when you have multiple sources of photon, you actually have more risk of error generation. If you have only a single source of light and the single source of light is generating the signal and idler, you have less chance of error too. So there's another advantage to our architecture.
Thank you.
Sure.
Absolutely. Well, thank you so much, Sumit. Definitely leave your contact information. I'm
Sure.
a broken record, but yeah, leave the contact information. Thank you for the presentation.
Thank you.
Yeah, absolutely. Next up, Tom, you're up.
Yeah. Okay. Let me get the
And just a full disclosure, we booked this showcase to end on the hour. So ideally, I just don't I want to give you the best chances. So ideally, if you can time wise, if we could stick to getting to the Q&A before 56, I think that will give us enough time to have some questions. Because I know people have other commitments sometimes.
Sure. 1 second. Sure, I'm trying to get to Zoom here. Okay, there we go. Let me see if I can do the share. Yeah, let me know if you can see my screen.
Yep, we can.
All right. Hello, everyone. I'm very grateful to Deep Tech Showcase for giving me an opportunity to speak. My name is Tom George, and I'm the founder and CEO of Sarania Sat Incorporated. From a microelectronics and semiconductor perspective, in the famous words of Monty Python, I'll be talking about something completely different. Rather than talking about novel microelectronics and semiconductors, I'll be focusing more on applications, specifically defense applications. And so I'm therefore happy to present our HEMI solution, which stands for High Performance Edge Computing with Advanced Artificial Intelligence and Machine Learning Algorithms for moving target identification and intelligence surveillance and reconnaissance. So Saraniasat's key value proposition is to provide timely and actionable information to the warfighter with low uncertainty in terms of low false positives or misidentified events and low false negatives or missed events. We are a dual-use company specializing in early warning of crop stress for our agricultural customers and for our defense customers, moving target identification and ISR. Our ultimate roadmap calls for launching a constellation of low Earth observing satellites, acquiring high spatial, temporal, and spatial resolution Earth observation data with a data rate estimated at 155 gigabits per second. So this cannot be downlinked and therefore necessitates the need for high performance edge computing to deliver actionable information with low latency to our defense and agricultural customers. Some additional honors for SarniaSat include highly competitive selection and admission into 6 leading commercial and defense accelerators. So SarniaSat recently concluded a Hemi demonstration for our NATO and defense customers, for which we selected an asymmetric warfare as the critical use case. In this scenario, as clearly shown in the current Russia-Ukraine war, a swarm of relatively cheap drones can destroy far more expensive military hardware such as bombers, tanks, and ships. Specifically, we are addressing the problem of identifying and tracking individual drones within a drone swarm that are otherwise undetectable by conventional methods such as radar. For demonstrating this challenging use case, we have been fortunate in assembling a highly qualified multi-institutional team consisting of my company SarniaSat, the NASA Langley Research Center, SRC, and the US Air Force Research Lab for the design and implementation of the Hemi solution. And now a little bit about individual team member capabilities. My company SarniaSat successfully demonstrated airborne moving target identification of a single flying airplane within a highly cluttered 100 square kilometer satellite scene in under 45 seconds using our deep learning algorithms operating on a high performance edge computer. Our team member SRC successfully fused video camera imagery with event camera imagery to identify and track a single flying drone. And NASA Langley Research Center's portable infrasonic microphone technology successfully generated 2 simultaneous micro UAV tracks. And all of these multimodal sensor inputs are then fused on the Intel Loihi 2 neuromorphic chip using spiking neural network algorithms specializing in individual drone identification and tracking. The Intel Loihi 2 neuromorphic chip has a fundamentally different ultra-low swap architecture compared to the traditional x86 microprocessor. The neuromorphic chip mimics the human brain in that the computation is done asynchronously by elements called neurons that spike based on the information content of the data. And so it is ideally suited for sparse events such as the identification and tracking of drones within a drone swarm, and for the fusion of several multimodal sensor inputs, which are also asynchronous by definition. And last but not least, we are excited to begin the development of generative AI techniques to synthesize multiple views, synthetic views on the right of a target based on a sparse sensor data on the left, and thereby create a full 3D view of the target. And so with that, I'd like to thank you all for your attention and welcome any questions or comments.
Thank you, Tom. Opening up the floor. I'll happily I could do it. I just don't want to be a
Put me
hog,
on
you
the
know?
spot.
I don't want to. Zach, you
Yeah,
want to?
I can ask another question.
Go for it.
Curious if you own any of the downlink or you're mainly on thermal and like imaging sensing.
I'm sorry, could you repeat that
Do
question,
you, do
please?
you own any of the downlink?
In the sense that we own the sensor data. I mean, so the sensor data comes in, right? And so we fuse that sensor data. We are agnostic to the downlink. In particular, because we are an edge computing solution, we will be on the data acquisition platform itself. So thereby cutting the latency that is involved in the downlink of the raw data down to a cloud on the ground or terrestrial cloud or server on the ground. So the idea is to rapidly fuse the data from multiple sensing modalities and provide a robust targeting answer, right? And because each sensor has blind spots, and so you can get misidentified events or missed events based on those blind spots. And so by using multimodal sensing, you cover each sensor's blind spots.
Got it. Thank you.
You're welcome. All right, Asher, are you going to put me on the spot again?
I'm just gonna, you wanna talk to us about a little bit about what you're doing? Because I think it could be relevant to some folks in the audience in terms of partnerships with, drones and the like. You want to talk a little bit about what you're working on? Or I'm not sure if you're allowed to talk about that. But in terms of like the object detection and that kind of stuff.
Yeah, so in general, we are interested in low swapC edge compute because drones don't have a lot of power on them, right? So and also they don't have a lot of size, weight, and mass carrying capacity. So something that fits within the payload carrying capacity of a drone would be wonderful, and the ability then to synthesize different sensor data on the fly. I mean, we provide the algorithms essentially, right? And so having a compute platform such as this neuromorphic chip would be something great. I mean, so we are always on the lookout for providers of compute platforms.
Yeah, absolutely. Well, if there's no more questions, thank you so much for presenting, Tom. I always enjoy your presentations. It's always
Thank
good
you.
to see you. And thank you everyone who joined the showcase. This one is going to be short and sweet. Thank you to all the panelists. Thank you to all the companies. We really appreciate it, everyone making time today. And feel free to join us next month for aerospace and defense.
Thanks,
Bye-bye.
everyone.
Thanks, everyone.
Thank you.
Thanks,
Have a
Asher.
good one.
Thanks, everyone.
Thank you.
Yep.
Thank
Bye-bye
you.
now.